Hey, so today I wanted to talk about open source models while we try to solve a complex problem. I've been using Minimax 2.5 and GLM5 a lot, and I've seen these models perform really good. A lot of things that we do on construction jobs, like writing contract, making proposals, looking for change orders, writing Excel sheets, writing all sorts of Word documents, and safety reports and whatnot. These models are really good at those kind of stuff. I would even argue that these model rivals the ones like OpenAI's models and Claude's frontier model. So we can get a lot of juice out of these models if we use them correctly. Obviously, they are not the frontier model. So letting that aside, we should really care about open source models because you can take the weights of those models and nice beefed up GPUs, and you can put those in your server room or in your cloud, and you can run those models. And when you run those models that way, you are now very sure about the data not leaking, because general contractors and owners, they always have this anxiety about the data, their pricing, their trade secrets leaking through OpenAI or Claude. But when you put these models in a closed boundary, you are very sure that you are not leaking that information, and you alone own that information. So without further ado, let's dive a little bit into the problem that we are going to solve. We are going to use Minimax M 2.5, GLM5, and Opus 4.6, and Claude and OpenAI's 5.2 model to solve this problem, and we'll see how this problem fare against different provider and what should we expect from open source currently. So to do this, I have taken a problem of resource allocation and I have given to four different agents. One of them is Minimax. I have written Minimax. It is solving the problem. I have given this problem to GLM5, I have given to OpenAI agent and Sonnet agent. So all these four agents are trying to solve this problem right now, and they are taking different approaches, different mathematical formulation to solve this problem. And we will see like how they solve the problem at the end. But let me explain the problem that I gave these four agents while they are trying to solve it in the background. So if I go here, and I think I put the problem here. Okay. So let me explain what the problem is, what the solution is, and what the AI agent are doing. So this is a resource allocation problem for multi-project environment. What it means is that we have three different projects that we have assumed: alpha, beta, and gamma. They have different values, different duration, and different priority. Important thing to understand is there is a penalty per week every time you go over the allocated schedule of 18 months, 14 months, and 16 months. Another complexity we have for this problem is there are activities A1, A2, B1, B2, G1, G2 for alpha, beta, and gamma project respectively, and they have different duration 4, 6, 3, 5, 4, 7, and we have within those duration requirements for different resources which are listed below. Like we have two project manager, three structural engineer, four cranes, excavator, skilled laborers. So we have to allocate these shared resource pool to these different projects and their activities within it. So what we need to ensure is that we can meet the given deadline and also not incur any penalties, and we have enough resources to cover this project. Obviously there are other complications in the real world, like there is time for moving the cranes and excavator, which we have not considered. This problem is somewhat simpler for humans, but this is a complex problem for AI agents. If I go into the solution, okay, here's the solution. The solution is simpler, that we cannot do these activities in parallel, so we have to use project scheduling. So one activity after the another, sorry, we have to complete one project after another, and that way we complete the whole thing in 29 weeks. There will be no delays, there will be no penalties, and we can effectively allocate our resources, shared resources within these three projects easily. So that's the solution. The great thing about this problem is it's very easy for human mind to understand, but it's very difficult for AI agent to understand. So they have to do some mathematical formulation and calculation, which is common even if this problem was like 10 different projects with different 1,000 different activities and a large shared pool of resources. The mathematical baseline or mathematical formulation for solving this kind of problem is the same, and that's why we can see how AI agent will perform on solving this problem um, against uh, against each other. So let's go back to our chat and see how our agents are doing. So Minimax is still taking some time. Minimax is a great model. It is faster, so that means that it can solve the problem really fast, and the quality of this model, it compares really well against agentic models like GLM5 or even Opus. GLM5, it is. This is interesting. Like the because the problem is really well defined in our problem diagram, like in our problem write up, we've written the problem, we have given it as a graduate level question that the AI need to solve. It has four different type of solution or four different parts to the solution that it need to present, and that's why if you look at the task that GLM5 decided to do, it matches with the task that Minimax decided to do as well. All right, so now it's time to check if our agent have completed their work or not. So Minimax, it's finished working. GLM5 still going strong. It's been a lot of time, but this is really heavy and really slow model. So that's that. OpenAI is still working. It's writing its answer. It's finished working, but I asked it to write the answers in a file. So that's what it's working towards. And then we have finally Sonnet, which has done its own solution. So let's go for one by one, and we will look at what the Minimax Minimax has done. This is this model, Minimax M2.5. So it has given us a histogram before leveling, after leveling, resource utilization, and it has given us the final summary. So this is the solution by M2.1. Good solution. It explained why it solved that, and it gave us some reasoning. And if I look at the logs, it it simply wrote the answer. It didn't do any mathematical calculation. It simply wrote the answer. So you should be very careful about using this kind of answer because it might hallucinate, and you should ask it to run these calculations before you take its word for the face value. So now GLM5. So this is a good way to demonstrate the capabilities of GLM5. It is a good model. It can run for long, and it gives us good answers. But at the same time, this model is really slow, and it takes a lot of time, and it is very verbose. So it just keep outputting lots of token until you get the results, and you are burning money. OpenAI is an interesting one. So basically, it didn't use any of the tools. In this kind of scenarios, I will be little hesitant to use the answer as it is. I can steer it in the right direction, saying maybe you want to run the calculations before you give me the answer. And this was OpenAI, so I was just going to keep it OpenAI consistent. So we know that the answer we are getting is ran through mathematical models before we can accept those. And let's talk about Sonnet. I think Sonnet is going to be my favorite answer, my favorite model. And I've seen again and again, like of all the available models, when it comes to this kind of stuff where you have to do some mathematical calculations, you have to take the results and do something else. Sonnet models are really good at those kind of stuff. There hasn't been any kind of interaction. It understood the problem well. It didn't ask me for follow-up questions because I've written the problem really well, so it should know every aspect of the problem by itself. And so it didn't like bother me for like feedback and stuff. It just kept going on its own. And so it's also not only delivered the answer, it has written multiple files with different kind of solution. It has written the Excel analysis, so it has given us the Excel model for it. And it's, if I look at the Excel model, it's built really well. It has built the tabs for resource analysis. It has built for tabs for project information and all those things, activity details and leveling marks and all those, and then so I can readily use that in my project. So really good job there. It has also generated some Gantt charts for me to look at for parallel scheduling, serial scheduling, resource level scheduling, all those stuff. Resource histogram. This model understood the assignment really well. And then summary comparison. So of all the models, like by far the best is Sonnet Min. So I wanted to cut back and showed you how the results from the GLM5 looks like. It's finally finished doing its work after such a long time. The formulas and all look correct. I have to go into more depth into analyzing those things, but it looks correct on the surface. It has explained the problem well. It has come up with the complete solution, and it gave us its reasoning. It built out the tables. It wrote the mathematical formulas. It wrote the solver, and it finally wrote the answer. So very detailed answer. It went into the depth of the question and solved it. It also gave us all the charts, Gantt chart, and the histograms that we can look at. It also gave us the improvement table. So overall, really good performance by GLM5. I can compare this performance with Sonnet, and then Minimax had good performance. So that's all. The open source did really good work, and this problem you can really see why people prefer still the frontier labs, because not only the quality of the answer but how it presented answer in Excel charts and all those really matters. But as far as concerning the right answer and presentation, all the models are there.